So hello there. We're going to continue with our videos in mathematics in the modern world, and we're going to talk more about this module in problem solving with patterns and puzzles. So we have stopped from the last videos in Pascal's triangle. We're going to continue now with what George Polya suggests to to work on whenever we are tackling problems that doesn't have any pattern with them. So this George Polya's problem-solving strategy, that's George Polya over there, works on any discipline, uh, but works well, of course, in mathematics. So let's start with a quote here by George Polya. He said that a great discovery solves a great problem, but there is always a grain of discovery in the solution of any problem, which means that in along the process, along the solution, not only on the final answer, but on the solution of the problem, there will always be a little bit of a grain of discovery there. Your problem may be modest, but if it challenges your curiosity and brings into play your inventive faculties, and if you solve it by your own means, you may experience the tension and, of course, enjoy the triumph of discovery. So this we always experience this triumph, this kind of success, every time we answer some patterns, problems, making use of our what do you call it? Using our own hands and using our analysis. Especially we experience this when we answer problems in mathematics, wherein it may be challenging at first, but at the end of it all, when you tried your best and solve it successfully, you will have this taste of success. So Polya gave us this problem-solving strategy. Remember that previously in Fibonacci, in the Fibonacci sequence and the Pascal's triangle, the ones that we have mentioned are just a few found by mathematicians in playing with numbers. There are some as well being used to solve problems, such as probability, the binomial distribution, the binomial expansion in the Pascal's triangle, which contains this binomial pattern. However, if you're given a problem without a certain pattern, say for instance, how would you attack and solve the problem? So George Polya outlined a strategy for us so that we can attack um, any problems in mathematics, which is also applicable in any discipline. So Polya generates or gives us this four-step problem solving strategy. He said that there are four steps so that we can successfully um, answer one problem, making use of problem solving. He said that number one, we should start with understanding the problem. Number two is devising a plan. Number three is carrying out the plan. And number four would be review the solution. And then we're going to talk about more of these um, one by one. Number one would be understand the problem. This is the part of the problem solving process wherein it's always neglected. It's always going to be neglected. So we want to emphasize, I want to emphasize to you how important the understanding the problem is, because this is where everything is set up, the foundation of any problem given to you. So in order to solve a problem, you must know the given and the asked. Remember, maybe some of your um, teachers in grade school or maybe in middle school or high school told you something about this gas. Gas stands for given, asked, and solution. So understanding the problem means that you can generate or you can extract the given and the asked here. Okay. Furthermore, you must see to it that you can restate the problem in your own words. If you can successfully do this, this means that you are understanding the problem because you can restate it. Whatever restating it will happen, you can still understand how the problem works. These are also some tips wherein how can you these questions can help you understand the problem even more. Asking questions like, can you determine what is known about these types of problems? Is there missing information that, if known, would allow you to solve the problem? Number three, is there any extraneous information that is not needed to solve the problem? Seldom we give some extraneous information to double check if you really understand what is asked, and only utilize the given, which could attack or which could hit those what is asked question. And then what is the goal of the problem? So basically, this is the number one, the first step, understanding the problem. You must, of course, do this as the preliminary step before we can carry out something that we want to apply in the problem. Number two would be devising a plan. or to devise a plan. For this step, we must um, explore what strategies can we do so that we can attack and hit the problem successfully. Some of which we can, with some strategies that we can um, recommend are these, but not limited to these. So, for example, you can use a list, you can use tables or charts, you can draw a diagram, working out the pattern backwards, which is a popular way to do so, looking for a pattern, trying to solve a similar but simpler problem, making an equation, and simply guessing. So these are some of the plans that we may encounter when we are devising a plan. Or rather, these are the ways, the strategies rather, sorry, the strategies that we can do whenever we are devising a plan. Now, devising a plan is not enough, of course. We must implement the plan and see how it works. So we will implement what we have planned, and then let's see if the problem is solved. If the problem is solved, so we're done. Okay, we'll proceed to the next step. If ever the problem is not yet solved, we will try to apply or find a new course of action. Okay, we may either improve the current plan, or maybe we can find a totally different new one. We can have this bullet so that can help us. We must first work carefully. We must keep an accurate and neat records of your all the attempts, or else if ever there are duplicates, it would be redundant for our work, so that you will be aware that, hey, I have already tried this, and then you'll get to know that. Number three is realize that some of the plans that we will be using may not will not work that well. You may need to devise another one or modify it, like I said before. So in carrying out a plan, please be patient in this part. You There's some time that there will be a lot of repetitions for number two, number three. If ever um, you are not successful for number three, you really need to go back to number two, which is devise another plan. So and then you go back to number three, two again, going to three. You need to have a lot of patience in this part in order for you to until you will solve the problem. Whenever you solve the problem, we're not done yet there, because you need to then verify the solution that you've had rather. So in equations, in given equations, it's clear on how to check it. You can check, double check, cross check, triple check, and counter check the given roots or variables just by inputting it on the mother equation above, right? So um, basically, you're asking, is your answer reasonable? That's simple as that. Okay, is your answer reasonable? For instance, you're solving something like in geometry or basic geometry, like solving the perimeter of a box or a square or something, and then you ended up with a negative length, which is kind of silly, of course. We don't do negative measurements in our world, so therefore this tells us that that is totally wrong. Okay, so because we don't have any negative measurements all in all, so make sure that whenever we are um, reviewing the solution, it should be consistent with the facts of the problem. It should not get away from the problem. It should stay within the context of the problem. And you should ask yourself whether there are generalizations that can be, generated from that solution. And pretty much those are the four. That is the four-step solution or problem-solving strategy by Polya. Again, let me recall that. Understand the problem, that's number one. Devise a plan, number two. Carry out the plan, number three. Review the solution, number four. And we can actually create a flow chart about this. So, say for instance, I will start. We'll start here. Going down, it's a prerequisite to start with number one, which is understanding the problem. Okay, first and foremost, you should understand the problem pretty well. Number two would be you need to devise a plan. That's number two. Number three is where we can decide already. So I'll make this as a diamond. And for number three, it's either yes or no. When you carry out a plan, if it's a yes, you continue to the next level, which is number four. This is a yes. If it's a no, this flowchart will tell you that you need to go back to number two to devise another plan. It may be modification, it may be totally new. Okay, but the thing is, you should devise another plan. Now, if ever it's a yes for number three and you carried out the plan and you answered it successfully, the next question would be number four, verify the solution of the problem. Maybe there's something wrong. If it's a no, so maybe you either go to number two or number three. I will choose number three here. You need to go back to these numbers because maybe there's some error while you are carrying out the problem. So you go back first to number three. If it really is wrong, you need to go back to number two. Okay, and then after number four, I think I need to put it here. This is where we will end now. Okay, meaning the problem is solved if it is a yes and if it is successful. Okay, so this is a simple flowchart on how to make use of Polya's four-step problem-solving strategy. First, we start with understanding the problem, and then we devise a plan. After devising a plan, we carry out the plan. If the plan is not successful, you go back to number two, devise another plan, modify the plan, and then you try it again for number three, and then until you will get a yes for number three. Now, for number four, you need to review the solution, check the veracity of the work. If there's some error, so you go back to number three, maybe you can fix the error there. If it is really that much broken, you need to go back to number two. But if it's a yes for the review solution, meaning the answer jibes with the facts, so there you go with the end, and that's how you can do Polya's four-step problem-solving strategy. So that's it for this very first video for George Polya's problem-solving strategy. I'll be providing exercises or examples in the next few videos. Thank you very much for watching. I hope you would like and subscribe, and see you soon. Bye.